Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Today I want to present about my project with title which is Convolution Neural Network for Oil Pump Ripeness Classification. First of all, I want to introduce about myself and my supervisor. My name is Hanafi bin Mohtar and my supervisor is Madam Munirah Binti Rahman. First of all, I want to introduce about oil palm fruit, which is palm or its scientific name Elias Venices jack, originates from West Africa, and it was first brought into the British country to be used as an ornamental plant. Large-scale oil palm cultivation in Malaysia was introduced by the government in the 1960 series. The value of palm oil and derivative export jumped 40% from Rm 65.3 billion ringgit to Rm 91.4 billion ringgit for the period January to November 2021. Palm oil industry is the fourth largest contributor to the national economy, and palm oil is also the largest contributor to Malaysian commodity export. Next, we go to the problem statement for this project. First problem statement is some smallholder lack knowledge about maturity and do not understand which color represents the optimal maturity of palm fruit to be harvested. The second problem is the lack of such a system providing a maturity introduction also encourage study to develop expert system based on image processing. And last problem is the categorization of oil palm fruit bunch according to their maturity. Next, we go to the objective. The first objective is to apply the SNM model of deep learning by using 10 categories of oil palm FFB for ripeness classification. Second objective, to assess the SNM model performance of FFB ripeness recognition in terms of training accuracy and validation accuracy. And last objective is to compare the performance with another SNM model using the same dataset. The scope project is this project uses a SNM model with 10 class classification, which is bunch, right bunch, underripe bunch, overripe bunch, damaged bunch, loose bunch, empty bunch, dirty bunch, small bunch, and rooted bunch. Dataset of oil palm FFB is 1552 images. The assessment performance parameters are training accuracy and validation accuracy. Mobile version 2 model will be used for performance comparison. Workflow of the project. First point, capture image oil palm FFB. The method used to collect the dataset in this study was by using the ASUS ZenFone 5Z brand smartphone camera. The location near my house and the garden area that my father managed, which is Perak Raja, Batu Pahat, Johor. At 7:30 am to 11 am, the image of the oil palm FFB was taken because the time was suitable to carry out activity to convict the oil palm FFB. There are several weather conditions involved when the dataset collection activity are carried out, namely cloudy, drizzly, foggy, dim, exposed to sunlight, and even in the evening. 10 categories of oil palm FFB with their picture will be used as the dataset of this study. Next, dataset. The total number of dataset of oil palm FFB after the collection process of 1552 images represent all categories with JPEG format.
and the data set will be uploaded into Google Drive. After that, we upload or link the dataset into Google Colab. Then resize and split dataset. Resize the all image dataset and split the dataset into two sets, which is 80% for training set and 20% for validation set. And then we build and train the CNN model. Use data augmentation and drop out to reduce overfitting problem. Using Google Colab to build CNN model and mobile version 2 model. CNN network as a main model for this project, and then mobile net version 2 network for comparison performance accuracy. Train that network using 10, 20 and 30 epoch, and then lastly show the result in the graph. Network performance and evaluation. After the training process, the performance of the CNN model used will be evaluated using the convolution map function to make performance comparison. This function is used to generate and display a convolution metric. In this cases, the result of such performance metric will be considered based on the value of accuracy, specificity, sensitivity, precision, error rate, and false positive error rate. Based on the figure, right, they are the formula that we want to calculate. Predict new image. At the end of the process, by using the image from the Google website to expect the image of the all.fab is in what category. Copy image address to do this process. This process is carried out to determine the section or failure of the network generated in the project against the new image. For the result, this is the result for CNN model and mobile net model that we use 10 epoch in their training and validation. Next, we go to the result for new image after we training and do validation process for two model network, which is CNN model get 89.70% for that figure, which is the figure red bunch that the predict for CNN model is true based on the title color green in the up image, and mobile net version 2 cannot detect for the new image based on the title, which is color red, and the predict which published 14.38%. Next, we'll go to the seterusnya kita pergi ke result untuk CNN model and mobile net version 2 yang menggunakan 20 epoch. Ini adalah menunjukkan graf di mana graf line berwarna biru adalah training dan graf line berwarna oranye adalah validation. Untuk result kedua-dua model menggunakan gambar yang baru bagi 20 epoch. CNN model dapat mempredikkan gambar baru tersebut dengan persentage 99.65% berdasarkan tajuk nama yang ada di atas gambar tersebut yang berwarna hijau. Manakala mobile net version 2 tidak dapat mempredikkan gambar baru dengan persentage 18.28%. Seterusnya kita pergi ke result untuk CNN model dan mobile net version 2 model dengan menggunakan 30 epoch. Berdasarkan kenaikan yang kita lihat tadi antara 10, 20 dan 30 epoch, terdapat kesan overfitting di antara kedua-dua model CNN model dan mobile net model. Di mana kita boleh lihat kesan tersebut adalah di antara jarak akhir 10, 20 dan 30 epoch tersebut antara training dan validation process begitu ketara di hujung ni dengan hujung. Sama juga dengan mobile net version 2, hujung pada titik 30 epoch antara training dan validation process. Untuk result yang baru, CNN model tetap berjaya mempredikkan gambar tersebut dengan 99.99%. manakala mobile net version 2 masih tidak dapat mempredikkan khabar tersebut dengan persentaj 14.89%. Ini adalah result apabila kedua-dua model menggunakan 30 image random yang diambil daripada validation set, di mana CNN model dapat mempredikkan 16/30 image dengan betul, manakala mobile net version 2 mempredikkan 14 daripada 30 image dengan betul. Next, kita pergi ke video demonstration CNN. Address tadi kita ubah nama dekat your predict. Your predict ni maksud kita predict gambar tersebut dekat kategori yang mana. So kat sini saya rasa gambar ni menunjukkan tandanya masak. So kita tulis nama dia right bunch. Untuk yang image part ni, dia akan rujuk dekat file right bunch. Dan kita run coding. Mari kita tengok result ni. Dan model CNN sequential ni membuat tekaan yang tepat sebanyak 98.10% confident bahawa gambar tersebut adalah right bunch. Warna hijau bermaksud predict model CNN dengan predict kita buat sama. Dan kita boleh tukar lagi, cari lagi tanda yang mana kita nak tengok. Untuk yang ni, copy image address dan kita pastekan email address tersebut dalam coding. Kat sini gambar ni menunjukkan buah kelapa sawit belum masak, so kita predictkan unwrap. Dan dekat image part kita rujuk pada folder unwrap dan kita run coding. Dan resultnya adalah model CNN berjaya meneka sama dengan apa yang kita jangkakan sebanyak 96.90% bahawa gambar tersebut adalah right bunch. Okey, itu saja untuk demonstrasi bagi model CNN sequence. Seterusnya kita pergi ke demonstration mobile net. Untuk gambar yang pertama, saya uji gambar yang ini, copy image address, kemudian kita pastekan dekat bahagian image URL. Setelah kita paste, kita predict kan sebab gambar tersebut dekat tandan mana, tandan apa. Kat sini saya predictkan dia adalah unwrap sebab kat sini nama dia unwrap, so kita predictkan unwrap. Dan kita run. Kita tengok hasil resultnya. Model mobile net version 2 mempredikkan gambar yang baru ini sebagai right bunch dengan persen 11.26. Predik yang kita jangkakan dengan model mobile net adalah tidak sama. Seterusnya kita uji dengan gambar yang lain sebagai underwrap. Dan kita run. Mari kita tengok hasilnya. Sama juga dengan gambar sebelum ini. Mobile net version 2 mempredikkan Gambar ni sebagai alat bantu. Apa yang kita jangkakan tidak sama dengan apa yang mobile net jangkakan dengan persen 12.32. Untuk conclusion, to make deep learning effective for classification application, it requires a large data set so that the overfitting effect during training and validation does not occur. Moreover, the best accuracy detection can be achieved by selecting the optimal number of inputs to train the CNN model. For the conclusion of this project, the CNN model gets better accuracy than the mobile net version 2 model in the process of classifying new image of oil pump FFB. For future work, experiment on different models with proper modification can be carried out in the future. This project can be continued by creating an Android application to provide knowledge about oil pump FFB to users who are out there. That's all for me. Thank you for watching and listening.